इस जमीन को क्या चीज उठाए हुए है? After all, everything needs something to rest upon, right? So there is this bottle of water, it's resting on the table is resting on the floor is resting on the foundations of this building. What's that resting on? सवाल है. And सबसे बड़ी बात ये कि हम यहाँ पर क्यों हैं? Why are we here? What put us here? So I'm not going to be able to give you answers to all of these because I don't know the answers and nobody knows the answers. But let's talk about them. There were very wise people in the past who talked about these. And they talked about the meaning of life, how we came to be here, whether there is order in the cosmos. Now, the ancient Greeks, they believed in the gods. There was Zeus, the Maha-god. There was Apollo, there was Cupid, there was Dionysus, there was Hades who lived beneath the ground, there was Persephone, etc., etc. But when the question was, what holds up the earth? तो भाई सबसे बड़ा जानवर कौन सा है जमीन पर? हाथी है ना? तो जमीन हाथी के ऊपर रखी हुई थी, लेकिन हाथी को भी किसी चीज के ऊपर खड़ा होना है. क्या कहते हैं? कछुआ? हाँ, ओके, गुड. लेकिन कछुए को भी तो किसी चीज के ऊपर खड़ा होना है. कछुआ किस पर खड़ा होगा? दूसरे कछुओं पर. And all that line of turtles needs to go down, but what is that standing on? Answer, a big, big kachwa. So, of course, that's not very satisfactory for those of us who believe in science. And so, religions, all religions have come up with their view of how the universe came into existence. And the Jewish, the Christian, and the Muslim views of cosmology are essentially the same. Now, the Muslims will say, it happened with kun fayakun. God said, let it be, and it was. The Christians say that God up there made the world in 7 days, and on the 7th day he rested, and that's why you guys have a holiday on Sundays. You don't have a Sunday holiday?
We have Saturday.
Acha, wow. But in the rest of the world, it's Sunday which is the holiday. Anyway, you know, why do I need to tell you? You know better than I do. And then comes Shiv, and he destroys it all. But then, after that, what does Vishnu do? But we're not going to get into this, because every religion has its own version, and you belong to this religion or to that religion depending upon the accident which placed you here or there. Now, if you guys had been born in China, you probably would have no religion. I don't know if you have a religion now, but probably most of you are Hindus. Is that true? Okay. If you were born in China, you wouldn't have a religion. If you were in Pakistan, you would most likely be a Muslim. If you were born in Brazil, you'd be Christian, etc. So it's all accidental, and so we in science don't believe in accident. We want proof. So the scientific method is all about proof and observation. If you can't observe something, well, it could be there or not be there. It's like these spirits and these jinns. Do we know that they are there? Could be. Who knows? But As long as they don't bother us, as long as we can't interact with them, their being and not being is the same. You know, we were talking about Aristotle. So Aristotle was a very wise man. And he had an explanation for everything, including why this stone falls to the ground. Because a stone is a part of Mother Earth. And every mother wants to call its son towards itself. Yeah? Don't you run towards your mother once you get home and say, "Mommy, I'm here." So exactly the stone was doing that. Now, is it wrong to say that the stone is falling to the earth because it wants to get close to its mother? Is it wrong? Anyone, be bold and put up your hand and answer. Okay, what about you? Do you think it's right or wrong? Okay, all right. It's right. Wrong. How many people think that she is right? Okay, you do, okay. How many people think she's wrong? Boy, we have silent people here, huh? Okay, look, the point is, you can sit down. The point is that I don't know if the stone really loves Mother Earth, because they say that a stone, you know, you've heard of the पत्थर का दिल, पत्थर के दिल में कोई मोहब्बत नहीं होती किसी के लिए. So it could be that the stone has a heart, or it could be that it doesn't have a heart, but this is something that you can't say is either right or wrong because it has no consequences. I can break up a stone and look inside. I won't find anything, but then you can say maybe it's when you broke it, the heart went away. But it has no predictive power, so it's not a scientific theory. A scientific theory has predictive power. यानी कि जो आपने अभी तक देखा नहीं है, वो साइंस आपको बताएगी कि क्या चीज आपको जाकर देखनी है, और अगर वो चीज आपको मिल गई तो फिर आप कहेंगे वो साइंटिफिक थ्योरी ठीक हो सकती है. अच्छा, तो चलिए अब हम साइंस की बात करते हैं. ओनली साइंस. So what's the universe? The universe is everything. But it's not just the matter in the universe. Well, of course, the universe is made up of everything, but it's also, and I'll explain this a little bit later, it's space-time that makes up the universe. Space-time isn't that simple. Time isn't that simple as people used to think, as Newton used to think. Newton was a genius, but he didn't know what was going to come up 400 years later. This sort of thing, I think your physics teachers have already told you about, that you have molecules. Inside molecules there are atoms. Inside atoms there's the nucleus. The nucleus is very, very small. You know, if the nucleus is about this size, about the size of a cricket ball, the nearest electron is on the other side of Kathmandu. So that means an atom is mostly empty space. You think of atoms as being very small, concentrated things, but they're not. They're mostly empty. Well, there are protons. Within the protons, there are quarks. The quarks are held together by particles called gluons. And actually, most of my life, I've been researching quarks and gluons. But that's for later. You know of the 4 fundamental forces of nature. There's gravity, which makes things fall down. There's electromagnetism which makes the microphone possible, lights. It's because of electromagnetism that you have electromagnetic waves which carry energy from one place to the other. We receive light and energy from the sun through electromagnetic waves. Strong interactions, weak interactions, I'll leave that for your physics teachers to explain to you. It's a little bit more than that. And today we know that in the entire universe, all matter is made up of 18 fundamental particles, of which 6 are quarks, 6 are what are called leptons, and the rest are bosons. Have you heard the name Bose? Shatendra Nath Bose. Who has heard of him or who has not heard of him? Who has heard of Shatendra Nath Bose here? No one? Of course you have. But you know, I was in Dhaka last month, and there was a centennial celebration of Bose, and I was so happy that they celebrated him. I have to tell you about this guy. Sorry, I'm taking you away from the subject. In 1924, he wrote a letter to Albert Einstein. He said, "Professor Einstein, I have a view of what light is. Light is not made up of electromagnetic waves as you and Max Planck, he's a great physicist, have conjectured, but rather it is made up of small particles, and those particles are spinning, and it would be nice to call them photons." Now Einstein, he told Einstein, he said that I've sent my paper to various journals in the world, but they have rejected it. But can you please have a look at it? So Einstein looked at it and he said, "Wow, man, where's this guy coming from?" He translated it from English into German. He sent it to a German journal called Zeitschrift für Physik. It got published, and he was a hero. And so 100 years later, we are celebrating Shatendra Nath Bose. And this thing over here, which is called the Higgs boson, that comes from him. Okay, so those are the fundamental parts of nature. Huh? I've spent a lot of time working on quarks, but I don't want to take up time because there's so many more important things, and Jeevan will be angry if I don't move very, very fast, because he says I have to talk to you guys one-to-one, right? And now let me tell you a little bit about Einstein. So before Einstein, we used to think of time as a river that flows, and flows only in one direction, and flows at a constant rate. But then came Einstein, and he was worrying about the nature of gravity. Why is it that two bodies, two pieces of matter, always attract each other? And of course, Newton had an answer. He said, "Oh, I have discovered that apples fall to the ground, and any two pieces of matter will attract each other. The heavier they are, the more they will attract each other. The closer they are, the greater will be the attraction. But I'm not quite satisfied with this." And so Einstein's revolution, which was one of the deepest, or possibly the deepest revolution in physics, was to say that space-time is not something rigid, but rather it's like a rubber sheet. So if you put something heavy on it, it goes down. If you put something light, it goes down, but by a lesser amount. And now these will naturally want to roll towards that, and that's gravity. So let's never forget space-time. Okay, but now I have to get back to my main topic, which is the Big Bang, the creation of the universe. When did it happen? How did it happen? How did it evolve in time? And really the observations goes back to Edwin Hubble about 125 years ago. Hubble noticed this. He said, so you can see him looking through his telescope. He noticed that there are galaxies over there. What is a galaxy? Anyone? You tell me what's a galaxy. Yeah. Lots and lots of stars. Absolutely. A galaxy has got maybe a billion stars in it, or a billion or 50 billion stars. Sit down. But it looks just sort of, like a fuzzy blob to you. However, and there are billions of galaxies, okay? The universe is, I have to tell you, it's pretty big. Did you know the universe was big? But it's not just big, it's humongous. Now, you notice these galaxies here, all over. And what he's noticing is that the further away a galaxy is from you, which means us, the faster it is running away from us. That's Hubble's observation. And it then brings to your mind, hey, what's going on over here? Why are all the galaxies running away from us? Now you think of an explosion. If this is the center of a bomb, the bomb goes patak. Well, all the pieces start flying off. Those pieces which were moving the fastest went the furthest. And so this is what gives rise to the idea of the universe having an origin. Now, earlier on, people used to say, oh, the universe was always there. But Hubble's observation started to change things. However, and this is where Einstein comes in, you can ask, hey, why on earth is the Earth the center of the universe? This is like in the old days, everybody used to think that their village was the center of the universe. But Einstein gave us a different picture of how that could have happened. But before I come to that, see, in science you don't assume things. Here you have a principle by which you can find out that that galaxy is running away from us or is coming towards us. And it's the same principle that is used to detect an aircraft that is moving away from you or towards you. It's called the Doppler effect. And if you don't know about it, you learn about it from your physics teachers. This is Hubble's law. So the further away a galaxy is from us, the faster it is moving. See, all data has to be presented in terms of numbers. देखो, गपशप तो दोस्तों के लिए ठीक होती है ना, लेकिन जब साइंस की बात करनी होती है तो उसके लिए फिर हमें नंबर्स चाहिए होते हैं. Science is all about numbers. Science is all about mathematics. बिना मैथमेटिक्स के आप साइंस नहीं कर सकते. पहले तो फिजिक्स तो इम्पॉसिबल है. केमिस्ट्री भी बहुत मुश्किल से होती है. बायोलॉजी में अगर आप लोग बायोलॉजी में आगे चलेंगे ना, आपको पता चलेगा कि कितनी ज़रूरी चीज़ है मैथमेटिक्स. So how could everyone think of himself as the center of the universe? Now, here is where Einstein comes in and space-time comes in. So suppose you're an ant. Ant को हिंदी में क्या चूंटी कहते हैं? अच्छा, चलिए, हाँ, चूंटी भी समझते हैं. Okay. So here is an ant living on the surface of a balloon that's expanding. He will think that this is running away from it, but actually it's the balloon which is expanding. Similarly, he will think that this is running away from it, but actually it's the space-time that is expanding. So Einstein was able to put these two things together, and that leads us to the picture of the Big Bang. Okay, I'll come to this later. But one thing is, in science, you must have prediction. So Hubble was there in 1920s. Einstein's theory of general relativity was invented in 1916, 4 years before that. The whole idea of the Big Bang started to get accepted a few years after that, in the 1930s. In 1939, George Gamow, who's a very famous, very brilliant astrophysicist, he made the prediction. Prediction क्या होता है? कि आने वाली चीज को आप पहले से guess करते हैं, कहते हैं कि ये ऐसे होगा. Prediction ये था कि most of the universe should be made of hydrogen, 75%, and 25% should be helium. Not fully 25%, but 24%, and other elements here. So that was the prediction. चलिए, वो कुछ देर के बाद चुप हो जाए. Now what happened? हो जाएगा. Yeah. What happened was that a few years later, astronomers, because they had such good equipment and they had spectroscopes and they had telescopes, they were able to confirm this. And so the Big Bang then started to get proof. And there's a third thing, I won't talk about it. It's called the microwave background, the cosmic microwave background. CMB radiation, it's called. Someday you'll appreciate it more, but there are microwaves all around us. Of course, there are microwave ovens. You use them all the time. Those microwave ovens use microwave radiation, but this microwave radiation actually came from the Big Bang. And we can now look at it. Oh, I must go fast, very. So then, you have this hydrogen which is spread out throughout the universe, but they're in clumps. There's a clump over here, clump over here, clump over here, clump. Now you remember that any piece of matter attracts every other piece of matter, and so they'll all want to, this clump will want to condense. And as it condenses, it becomes hotter and hotter, and eventually it becomes so hot that a thermonuclear reaction starts. Energy starts being produced by nuclear fusion. And this is what gives rise to the birth of a star. So a lot of stars were made just 500 million years after the Big Bang. I say just because, the universe is pretty old. There are still stars being formed in the sky. You think, looking at the sky, that this is the way it always was, But look at it 500 million years later, and it'll look very different to you. So anyway, everything that is born dies. I will die, and you will die. And we think, okay, we are just humans, we will die, but what about the stars? Will they ever die? Why will they die? Who can give me an explanation? Extra marks for that. Why will the sun die? Will the sun die, first of all? Will it die? No, not die. Okay, you tell me. Huh? Huh? Beautiful. The hydrogen is being converted into helium, and so eventually, just like your car or your scooter will run out of petrol, the sun will die because it will run out of hydrogen. And you know how much our sun is consuming? It's incredible. 600,000 tons of hydrogen every second. I mean, it's crazy to consume that amount of fuel. But that's what keeps the sun going. So eventually all the stars will die out, but some of them die, just a normal death. You quietly fade out and you go away. You become browner and browner until nobody can see you. Not a very interesting death. But some of them blow up, and they're called supernova. Now, when a supernova blows up, it creates all kinds of elements. That's the so all the heavy elements. So everything up till iron and then beyond, up till uranium and further. You and I are the result of a supernova explosion that happened some 6-7 billion years ago, from which our sun came into being, and the planets, and the Earth. And there's a lot to be said about how the Earth was formed, and how these... So the Earth was too hot in the beginning for any form of... Well, it was just liquid. In the very beginning, it was liquid. That liquid still remains down. If you drill into the ground, if you go to the center of the Earth and a few 100 miles above it, it is pure molten iron. Pigla hua loha hai. And that's the early origins of the Earth. But then the Earth started cooling. This is what led to land being formed. The land was very unstable. It was floating around on this magma. This is, as it cooled further, you had solid land. And we'll follow up that story, but these Himalayas are a consequence of that. Because you had different plates solidifying at different times, and then the one would rest on top of the other, and then someday something would happen and go slip, and there'd be a catastrophic earthquake. One plate would go under, the other one would come up. That's called subduction. But now I must move very quickly and ask life. So you had hydrogen, helium from the Big Bang. Then you had the heavy elements, carbon, oxygen, nitrogen, all the way up to iron. The 100 elements that you learn about in your periodic table, they came later. But that's just inanimate atoms. Where did life come from? Let's now talk about that. So first of all, we've got to decide what is life. How do simple molecules make complex molecules, and whether we are the only ones in the world? There's a lot of, every religion has a point of view on this. the Egyptians thought it came from the river Nile because the river Nile was the mother of Egypt. But everyone had a theory of life. So the Christians and the Muslims and the Jews, they believe in Adam as the first human. And I mean, there are 400 religions in the world. Everybody's got something to say. But you guys are learning science, and you're going to learn the scientific way of how to look at this. So the two possibilities: did life start on Earth, or did it come from elsewhere, from some other part of the universe, some distant part of the universe? Open question even today. We don't know. But let's ask. First of all, what is life? It's self-organization of molecules, sustainable with the power of reproduction. Life reproduces itself. But you know, that's not the only thing. Computer viruses also reproduce themselves. But there's something different over here. These are physical molecules, these are physical entities, not mathematical codes. What does it need? What does life need? It needs energy, it needs organic molecules, and it needs water. Why organic molecules? Why carbon? Why is carbon so very necessary? वो कार्बन के 4 डंडे होते हैं ना, देखे आपने? उसको क्या कहते हैं? वो जो 4 डंडे निकलते हैं ना कार्बन एटम में से, उसको क्या बॉन्ड्स कहते हैं. So carbon is tetravalent and it can make very complex compounds. It can make sugars, it can make proteins, it can make everything that there is around us. So we need that. We need water. Why do we need water? Because it's needed to carry nutrients from one part of the cell to the other. Then whatever the cell produces, which is excess, after it's used up the ATP, whatever, then you have to get rid of that, and water is very good for that. I mean, we don't know, but we think that these are absolutely essential. How was it before life arrived on Earth? It was pretty nasty. I mean, it looks beautiful, but this is sulfur bubbling up from beneath. There's ultraviolet radiation coming down from the skies. There was no atmosphere that could stop them. Things were extremely hot. These volcanoes were spewing out sulfur dioxide. Horrible, but beautiful. But there was lightning. There were gases. And so these guys, Operon and Haldane, by the way, spent a long time in Calcutta and in Lahore. He was a brilliant guy, chemist. So, you know, whether you study chemistry or you study biology or you study physics or math, as long as you're good in what you do and you put your mind to it, you can make your mark in whatever subject you choose. So anyway, what was this experiment? Here's water. Water is heated up by a Bunsen burner. Water vapor goes here. There's methane, CH4, ammonia, hydrogen gas, and water vapor. And now, just like in your motorbike, you have a spark plug. They have a spark plug over there. So then this stuff that comes out is cooled through this cold water thing over here. And you then send the sample for for chemical evaluation. What's it contained? What they found was stunning. They had amino acids. Now, amino acids are the building blocks of proteins, and there are 20 types of amino acids. So this was the first indication that life, not life, but the building blocks of life could come from simple atoms. You've heard about DNA, you know of the DNA being a long molecule with strands in between, with the 4 links, which are molecules as well. Life starts to emerge about 1 billion years after the Earth comes into existence. Those first living things were very, very simple, prokaryotes. But then they were rapidly displaced by eukaryotes, which had an inner core to it, a cell, and the first multicellular organisms start to emerge a little bit after that. And now these are things that you learn in your biology class, in your class on evolutionary biology. But let me tell you how long it took. So the Earth forms 4.5 billion years ago. For 1 billion or 1.5 billion years, there was nothing. But then these prokaryotes come into existence. From there to us takes 3 billion years. Now, our minds don't readily absorb that, so I'm going to give you a different way of looking at it. So suppose that the world comes into existence at midnight. From midnight to 6 in the morning, that is to say the first 1.5 billion years, there's nothing. Then come the eukaryotes, which are more complicated living organisms. And then you have the amphibians, the fish, the land animals, the birds, and all that is from 10 at night to 1 minute to midnight. And we are there in the last 1 minute. And of course, we didn't come directly to where we are. We came from the apes. Are you ashamed that you came from the apes? No. If somebody asked me who was my great grandfather, I'll say बंदर था, हनुमान था. क्या उसमें कोई शर्म की बात है? नहीं. कुछ लोगों को बड़ी शर्म आती है इसमें. Why? This is the way nature has actually happened. And so we probably look like this. Probably 2,000 generations ago we looked like that. And now this, I'm almost done. We fight amongst ourselves on the basis of race and religion and nationality. First of all, let me tell you how stupid it is to fight on the basis of nationality. There were no nation states until 1648. That's the Treaty of Westphalia in Europe. There was no France or Germany or Italy. There was no Australia. If you looked at the map of the world there, you would have seen empires. There was earlier on the Roman Empire. Coming here, you had the Mauryan Empire, you had the Mughal Empire, there you had the Ottoman Empire. But if you looked before that, the map of the world would be totally blank as far as national boundaries go. But race is another thing. Okay, so there are the Goras, there are people like us, brown-faced, whatever we are, I don't know. Some are very brown, some are light brown, some are almost like Goras. All kinds of people. Okay, where did we all come from? Here. You can't read it, but it says Adam and Eve over here. So 65,000 years ago, there was a mass migration out of Africa. And they went all the way up till Greenland. Oh well, you can see the migration maps. Here's India. From India, they go to here, Indonesia, to discovering Australia. And I think that people who know this scientific theory of races, of why is it that some peoples, especially Africans, are able to run so fast, and they win the Olympics medals because they were chasing wild animals. Okay? There are people who survive very well in cold climates. There are others who will die if they go to cold climates. All that is natural adaptation. And natural adaptation is something that Darwin tells us is natural. He called it natural selection. So, to the very last part of my talk, could there be life in other parts of the universe? Yeah, sir, but not in our solar system. We've looked at it, it looks pretty hard. If there is some kind of primitive life, it'll be very interesting. In Mars, okay, someday we'll be able to colonize Mars. Maybe your kids will, no, their kids, your kids' will be living on Mars, very possibly. By the end of this century, we'll have a colony of about 80 to 100 humans living on Mars. So when they look down from there and they look at us, they'll be looking as an advanced people on a parent colony that's still growing. What about people in the rest of the universe? We don't know. Anyway, I finished. And just to summarize, you can't argue with the Big Bang anymore because there's too much evidence. It's all consistent, and those who don't believe in the Big Bang, well, tell them to smoke something else. We don't know all that much about the solar system. We're learning. See, here's the thing about science. We're all the time saying that we're learning new things. It's like a building that's going up and up and up. We never say, this is the last story. We never say, the book of science has been written, it's complete, finished. But religions say that. They say, we are the last word. And so that's the big difference between religion and science. So we're learning more about life. We, as I said, don't know whether life came from outside or came from here. And evolution, Darwinian evolution, which you are fortunate to learn about in your school books, but we can't teach it in Pakistan. It's forbidden, sadly, because evolution gives you a full picture of how we came to be and of our animal roots. So that is extremely important.
Himalayan WhiteHouse International College. Identify the difference in you. Tinkune, Subhidanagar, Kathmandu.